Mike Bergen? Yeah, it sounds like it. Hello, my name is Matt Kessinger. I'm one of the co-founders and CEO of Forest Devices. We're coming to you today from Pittsburgh. I am a dual MD and master's student at Carnegie Mellon.
Hi everyone, my name is Carmelo Montalvo and I'm the Director of Operations at Forest. And I'm also a master's student at Carnegie Mellon. Stroke is the fourth leading cause of death, but it's the #1 leading cause of disability worldwide. And 9 out of 10 people who have a stroke will live through it, but 6 of those 9 will live with disability.
And it happens every 40 seconds. As a former EMT, I know just how important it is to identify stroke early. Time is brain, and even a few minutes can change a person's life forever. But there's a big problem. Outside of the hospital, with an MRI or CT, there is no objective way to easily and objectively identify stroke. In fact, pre-hospital personnel, all we have available to us are subjective clinical exams, which means, how does the patient present to me? Do I think that they're having a stroke? Now, that may be all fine and good if every hospital were the same, but only 1 in 7 stroke hospitals is a stroke center. And it's scary, but only 1 in 70 can provide all treatments for stroke 24 hours a day. This is what it looks like when we zoom out to the entire United States. These are CDC maps. All the crosses you see there are emergency departments where any ambulance could take you in the case of an emergency. These are the stroke centers where you should go if you're having a stroke. And these sparse collection of green dots are the comprehensive stroke center. Those are the hospitals that can provide all treatments for stroke 24 hours a day. Now, I learned this lesson quite early in my career, in fact. The first month I was on the job, we were called to the house of a woman in her 60s. She'd suddenly become weak and confused. So we put the EKG on her, we did our clinical exam, and we realized that there were half a dozen reasons why she could have the symptoms that she did. So we did what we were supposed to do, what we were trained to do, and we took her to the nearest hospital. Now, if this had been a trauma patient, and she'd been bleeding or had her arm broken and askew, we would have taken her to a trauma center. If the EKG had read heart attack, we would have taken her to a STEMI center. It's where you're supposed to take patients who have heart attacks. But we took her to the nearest hospital, and there she was diagnosed with a stroke, but it wasn't a stroke center. So she had to be transferred by helicopter to that stroke hospital. And that needless waste of time cost her 2 hours of brain. That was the difference between being able to walk out of the hospital and go home in a few weeks and never being able to walk again, having to live in a nursing home. It's the difference between a single hospital bill and requiring expensive medical care every single day for the rest of your life. And 2 hours is the average treatment delay when you go to the wrong hospital first. And it happens so frequently, we even have an acronym for it. It's called DITO, door in, door out time. So it's the amount of time it takes when you get to the wrong hospital to get out of the wrong hospital, get transferred to the right hospital. In fact, it happens to 1 out of every 2 stroke patients.
But if we did have an effective and objective way to screen for stroke outside of the hospital, we could save thousands of lives, reduce hospitalization days by hundreds of thousands. And 80,000 people would be able to go home instead of having to go to the nursing home. These clinical benefits translate into tens of billions of dollars in healthcare savings. This is the problem that Forest Devices is solving.
And this is the solution. This is AlphaStroke, the first line in stroke identification. With just a few electrodes, an EMT or a medic on a truck can identify a stroke rapidly and in any medical environment. Now, what's happening in the background is AlphaStroke's measuring asymmetry. So a stroke only happens on one side of the brain or the other. And so AlphaStroke can rapidly identify that asymmetry, which is characteristic of stroke. So beyond this basic EEG platform, we've also incorporated response potentials. So response potentials are stereotypical neurologic responses to controlled and repetitive stimuli. So if I were to find the light switch in here and flash it on and off, on and off, on and off at a specific frequency, and if I had electrodes hooked up to all the judges' heads in the back, I know what I would expect to see. So by using response potentials along with EEG that is identifying asymmetry, we can identify stroke even faster.
But to the user, it's straightforward. They simply press start, and then the test runs. They get a decision, and the decision is binary, either stroke or no stroke. It is this ease of use that allows AlphaStroke to be so versatile.
And that versatility is important because it's not just the pre-hospital environment where AlphaStroke can bring value. So let's say you're over 55, it's the middle of the night, and you have a splitting migraine. So you go to the ED, And even though you have no other symptoms and your chances of having a stroke are like 1 in 500, you're almost guaranteed to get a head CT. Now, I don't like to say it, but the main reason is because we live in a litigious environment, and we cannot, as physicians, walk into a courtroom with only our subjective exam findings. We have to have objective data to support our decision-making. So this translates into over 2 million unneeded head CTs a year to the tune of $2 billion. But let's say you're that person, instead of going to the emergency department, you went to an urgent care center. Well, the chances are they may not even treat you, and who can really blame them? Half of all malpractice suits against urgent care come from neurologic patients, and they don't have a way to objectively rule out stroke. And because stroke presents in so many different ways, they're really opening themselves up to liability. So, AlphaStroke can help urgent care centers keep those patients, plug that leak, and generate new revenue.
In the United States, we estimate about 100,000 users. In high-income countries around the world, we estimate double that. All told, we estimate a $3 billion addressable market with over $500 million in recurring revenue.
Now, we've touched on the 3 main segments. These are ambulances, hospitals, and urgent care centers. And it's really great that our first customers own portions of all 3 of these segments. Integrated health systems. Integrated health systems are large hospitals that are usually also payers. They own ambulances, and they own urgent care centers. So here in Houston, you have Memorial Hermann, Harris Health, and a few others as examples. Now, we have mapped out the adoption curves for each of these segments. We're going to begin by focusing on the incentives for those early adopters, those integrated health systems. So, the time we live in, healthcare is complicated, right? The reimbursement system is in a bundled payment. If you have a stroke, you come to my hospital, I get paid the same amount if you're there for 2 days or 20 days. In fact, the only difference in what I get reimbursed is if I can provide you treatment. But there's the catch. I can only provide you treatment within a short time window. So, if you get to a stroke center within 3 hours, you can get TPA, that's the clot-busting drug. And that hospital, their reimbursement goes up by over $5,000. If you get to one of those comprehensive stroke centers and they can do a thrombectomy, then their reimbursement goes up by over $15,000. So we are generating revenue for our customers while improving the outcomes of their customers, their patients. But we're also decreasing overhead. Remember, 2 days or 20 days, I get paid the exact same amount. But if you get treatment earlier, you get out of the hospital earlier. And it's been shown that 2 hours earlier treatment leads to about a day and a half of reduced hospitalization.
And we've validated this market. We've received letters of intent from leading integrated health systems from around the country. They believe that AlphaStroke is the next extension in their care for their stroke patients. They want to put this on their ambulances, both the ones they own and the ones they contract with.
And that's important because they own about 10% of the ambulances in the country and they contract with many, many more. So we can deliver this also at high margins. So taking a couple assumptions, we'll say that the price point is $10,000 and that the average lifespan of the device is 5 years. So given this, we can produce in bulk at over 80% margin. But there are also the consumables. Those are the electrodes, single use. Given that 5-year lifespan and an assumption of about 100 uses per device per year, we're basically doubling the revenue on each device. And by the way, we also have a leasing model and a pay-per-use model for different types of customers that have different capital constraints. So, taking that out a little bit further, with an assumption of only 4% of US market penetration 3 years after FDA clearance, we will hit a break-even point.
And as a medical device company, we're extremely cognizant of our regulatory pathway. In our FDA pre-sub meeting, they confirmed that they consider our device a Class 2 device. We are on the direct de novo pathway, and we are joint and priority review eligible. And we are now eligible, after last year's law change, for the joint FDA and CMS review, which means the day that we receive FDA clearance, we may also receive our CMS reimbursement code, shaving months off of our path to market.
And as a de novo pathway, we are leading, not following. So we can make our own claims, which can be barriers to entry for those that would follow us. And you can be sure that those marketing claims would reflect our IP. So besides trade secrets, to date we have one utility and PCT filed, no action items as of yet. We anticipate the first office action by the end of the year. Second, we have a second provisional file January of this year. We're on track to file 3 more by the end of this year. Our existing claims provide protection for the algorithm, device, and the process.
And this is the team that's going to make it happen. Steve Morrow is a Wharton MBA. He was at BCG and Milan prior to Forrest. Dan Willis is our CTO. He's an electrical engineer. He was at MSA, and he's the chief architect of Alpha Stroke. Steve Norcup manages our clinical relations, and Alessandro is our project manager. And T. Chen is our quality engineer, and Angelo is our lead software developer.
But we're not the only ones trying to identify stroke early. This is a CT ambulance. It has a CT scanner on board. In fact, Houston was the first place in the country to have one of these. It costs $1 million to build, and it has to be operated by either neurologists or nurse practitioners. It ain't cheap, but it saves money because stroke is that expensive. So if it's worth this much to identify stroke earlier, think about the value that we can bring. If we can do the same thing for 1% of the price, and it's simple enough that the medics and EMTs on the trucks right now can use it.
I mean, to be fair, Matt, there are other technologies out there trying to solve this problem that don't cost $1 million.
Okay, fine, but none of them are commercialized yet. All right, so there's some eye scanner technology out there. It's generally used to diagnose vertigo. It can identify about 5% of the strokes, the ones that happen in the back of the head. There's a microwave helmet out of Sweden, but its focus is in the emergency department because it's hard to put a helmet on someone in an ambulance on a gurney. There's also a blood test that is under clinical trial right now. They are also focused in the hospital. There's also transcranial ultrasound. Now, it can detect some strokes that are close to the surface of the skull. However, it has to be operated by highly trained technicians, and the results have to be interpreted by highly trained technicians. It ain't binary. So, AlphaStroke, our competitive advantage is that our speed of our test, the ease of our use, and the versatility that that brings. So, I want to tell you about some of the results from our initial trial. So, it's a feasibility study, 2 university hospitals. These are neurologic patients admitted to the stroke unit. One site is closed, one other site has a few more patients to enroll. Now, at the end of last month, we had 35 patients, 20 strokes, 15 controls, and we're really happy to say that the objective data that's coming from this little green box is already beating the pants off of the subjective clinical exam. So remember, about half of all stroke patients are going to the wrong hospital first. So even in the hands of a highly trained medic with lots of experience, they're getting about 75% accuracy. So though we have a machine learning trajectory, we've actually taken a couple different approaches to discriminate algorithm generation at this early stage. And even on the low end, we're pulling over 80%. So these are the numbers for our best performing algorithm to date. 85% of the strokes have been correctly identified, 4 out of 5 of the controls correctly identified. But all of this is leading up to the next study, an important one, and that's with emergencies patients. So these are patients that have symptom onset within 8 hours, and it's really important to our customers to call because that's the time window where they can treat and thereby increase their reimbursement. So in order to get there, where we've come from so far is a feasibility study raised a little over $500,000, but we're here today to raise $1.1 million, the capital of which will enable us to do a couple of things. One, to take this working, but early prototype to this stage 2 level AlphaStroke that will be successful in emergency departments and ambulances and integrated health systems. That capital will also allow us to put it in the ambulances and emergency department of an integrated health system. Subsequently, we anticipate 2 further rounds of clinical trials, each necessitating their own round of funding before FDA clearance and first revenue. So now to be specific, our next milestones. What do we need to get from where we are to where we need to be? Well, first off, we need to upgrade the form factor. So it's a new environment, it has new challenges. You can see we've already started that. But we also need to upgrade our electrodes. We need to make them CT compatible so that we're not interrupting the flow of care in the emergency department. We also need to improve our user interface. So we've put this in the hands of medics and EMTs, but in order to de-risk a large-scale emergency trial, we need to put this in the hands of medics and nurses and clinical coordinators that will be running the trial. Also, software infrastructure. So this needs a few different things. First and foremost, it's the expertise to take us from 85% to 99%. But it also means things like real-time processing and upload. So a little embarrassing, but every month we go to our hospitals and we open up the back of this and we take out the SD cards and we put them in the computer and we upload the data to our servers. Well, with a national trial, we need to be able to do that automatically and securely. So I'm running out of time, so we also need to have operational improvements. I'll just give one example. We need a CFO. So we're here today. We're here today looking for partners, and we're a great partner to work with. We have a validated value proposition and market. We have a relatively advantageous regulatory pathway. We've demonstrated capital-efficient operations, and we have mitigated technical risk. We're Force Devices, and we are making stroke decisions smarter.
Thank you.